Hello everyone, my name is Kian. Today I'll present paper Causal Intersectionality and Fair Ranking. This is joint work with Joshua Loftus at LSE and Julia Stoyanovich at NYU. Let us consider an idealized hiring process of a moving company that has a dataset of applicants including their gender, race, weightlifting score X, and overall qualification score Y, by which job candidates are ranked. The moving company wants to hire 4 best qualified candidates. The process by which Y is derived is hidden from us, but we observe each candidate's attributes, including their score. Consider the result and observe that only one female candidate and no black candidates are returned among the 4. Observe also that the weightlifting ability X maps to qualification score Y differently depending on gender. We may have reason to believe, based on our knowledge of discriminatory practices in hiring, that gender and race impact the qualification score Y. In this paper, we take an approach to fairness based on causal modeling. We assume that a suitable structural causal model is available that specifies relationships between variables, including the sensitive attributes, which define individual traits or social group membership relevance for fairness. The causal model is a statement about how the world works and is represented in a directed cyclic graph, or DAG for short, where vertices represent variables and edges indicate causal relationships from source to target vertices. We assume that the causal model describes the data generation process, including what would happen under interventions or counterfactual scenarios. And our goal is to use this model to produce a ranking that is fair with respect to multiple sensitive attributes and the intersectional subgroups of these categories. We define intersectional fairness by modeling the causal relationships between sensitive attributes and other variables in the DAG on the basis of not just one attribute at a time, but a combination of attributes, and then make ranking fair by removing these effects. Given a ranking task, a set of sensitive attributes, and a causal model, we propose ranking on counterfactual scores as a method to achieve intersectional fairness. We use the causal model to compute counterfactual scores Y tilde, the scores everyone would have under one specific combination of the sensitive attributes, gender and race in our example. We then rank the candidates based on these counterfactual scores to produce a ranking that would satisfy a causal and intersectional definition of fairness. The causal model can encode direct and indirect discrimination, which are shown in red in the DAG. Under U.S. labor law, the moving company may be able to make a business necessity argument for the weightlifting variable X. The DAG on the left shows the case where X is a resolving mediator, meaning discrimination on the basis of X is considered unenforceable. The DAG on the right shows the non-resolving case, where no discrimination is allowed, direct or indirect. We want to check whether such causal links exist in our data, and if so, to break them to produce fair outcomes. Our work aims to mitigate the negative impacts of ranking tasks on people due to attributes that are out of their control. In this work, we proceed with understanding that the model is a simplified and reductive approximation, and we support for transparent decision-making process to deploy an algorithm and claim its fairness goal by stating decision-makers' belief in the form of a causal model and not for rubber stamping. There are many issues outside the scope of the present work, but which are important in real applications, such as the choices of which attributes are sensitive, which mediators are resolving, and for which sensitive attributes. Although these issues may have adverse impacts when using our method, we do stress that these are not limitations inherent to our approach in particular. Rather, these concerns arise for virtually any approach in a sensitive application. Further, like any approach based on causality, our method relies on strong assumptions that are untestable in general, though they may be falsified in specific cases. The flexibility of our approach and its connection to causal methodology makes possible a great deal of future work, including exploring robustness of rankings to unmeasured confounding or uncertainty about the underlying causal model. Thank you. Questions?